Welcome to the A-Level Computer Science Taster Session. We're going to be looking at the factors affecting the performance of a CPU. First of all, let's think about what is a CPU. Well, a CPU stands for Central Processing Unit. This is the part of the computer that carries out everything. It's the brain of the computer and does all our instructions. Everything we do using a computer, from writing text to playing videos, is all performed by the CPU. As I've said, it's also called the brain of the computer. You have 1 minute. Can you write down as many CPU manufacturers as you can? Hopefully you've come up with some of these: Intel, AMD, ARM, Apple, Raspberry Pi, IBM, HiSilicon and Fujitsu. I wanted to think about why CPU speed is important. First of all, let's think of a BMW. You can get lots of different BMWs, they all have different engines and they all cost different amounts. They quite often look the same though. The outside they look the same, but some engines are much faster. This means it can go much faster and it has much better performance, but it's a lot more expensive. And this is the same with CPUs. The better the CPU, the more money it's likely to cost. You might not always need a fast CPU. If you're a gamer, you're probably going to want a fast CPU, probably with a GPU, to make sure that you can run your game and render graphics at the same time. But if you're only using a computer for a simple CPU, then you can spend less money. We can figure out how fast a CPU is by looking at the 3 C's: cores, clock speed and cache. First of all, clock speed. Now you can think of a clock speed like a clock ticking. Every second an instruction is carried out by the clock. This chip uses something called a vibrating crystal that maintains a constant rate. The speed of that clock is measured in hertz, which is represented by Hz. And that's actually the amount of these cycles that happen per second. So a clock speed on average might be 500 Hz, meaning 500 instructions or instruction cycles can be carried out every second. Current computer clock speeds are on average around 3 GHz, which means 3 billion of instructions or cycles every second. And the world record is currently 8 GHz, which was set in 2014. Now, the world record for the number of cycles and instructions that can happen per second, as we said, is 3 billion at the moment. Here's a quick video that you can watch to give you a little bit more information about clock speed. So we can actually change the clock speed of a computer, and that is quite a complex process to do. However, this comes at a price. Sometimes overclocking means that a computer can become very hot, and this can become dangerous and some of the components will start exploding. However, a faster clock means a CPU can perform more calculations, more instructions faster. You can actually improve the clock speed of most computers, but be careful when doing it. Here's a quick video of what happens when you overclock a computer. So we can actually improve a CPU by improving the number of cores that it's got. Imagine a core as running 1 instruction at a time. With the clock speed, remember that might be 3 billion instructions per second. If we have more than 1 core, we can double the amount of instructions a run. With 2 cores, we're doubling that. With 4, we're quadrupling it, etc. The number of cores needs to be built into the program, and this means we can process more data. Here's an example. 4 cores would be quad core. That means that 4 instructions can be run at the same time. This is called parallel processing, where the program can have 2 instructions processed at the same time. This feels like multitasking. So when you're on a computer, you might be running Spotify and you might also have a Word document open doing your coursework. Both of those might be using different cores. In effect, a quad-core computer should quadruple the speed. Our third C is cache. And CPUs can work really quickly, but they're actually limited by the amount of instructions and data that we can give them. If we store all our instructions and data in RAM, well, RAM is actually slower and works slower than our CPU. So to overcome this, in a CPU we have a small amount of memory called cache, and this stores frequently used instructions or data to make it much quicker. So I've found 3 computers here. You can click on each of these links to see them in PC World. Which one do you think is the quickest? Pause the video and see if you can figure that out. Actually, the fastest was the Lenovo. It had an Intel core. It wasn't the only one with an Intel core. The Apple actually also had an Intel core. Now, Intel is just a brand like BMW or Audi. It can have an effect on the speed of a computer, but this is more of a secondary effect. This is just depending on the components that they're actually producing and the quality of them. Think about BMW compared to Ferrari. You'd actually expect the Ferrari to be better, or the components to be better. But if you put the same engine in both of those 2 cars, you might actually see a small difference in performance because the Ferrari actually has better streamlining. However, in this case, the Lenovo has more cores, hexa-core, so 8 cores. It's the fastest clock speed, 3.6 gigahertz, so that means 3.6 billion instructions per second. And it has the most cache, 12 megabytes of cache. So within the CPU, it's got 12 megabytes where it can store frequently used data. So all for a similar price, I would recommend the CPU in the Lenovo. Here's an example of an exam question. A company is designing a new low-powered processor to be used in a smartwatch. The processor contains a control unit. Can you describe the role of the control unit? Thank you for watching. This is a really exciting course, and if you do want more information, then you can follow us on Twitter. Our handle is @TSC_computing, or if you do have any other questions, please feel free to email me.